Hello and welcome to this lesson on metals and nonmetals. In today's lesson, we will classify elements as metals or nonmetals based on their ability to form positive ions. Secondly, we will understand the distribution of metals and nonmetals in the periodic table. To classify elements as metals or nonmetals, it's crucial to understand several key concepts about the properties and location of these elements in the periodic table. Firstly, metals are elements that tend to lose electrons during chemical reactions, forming positive ions known as cations. This tendency to lose electrons is described by a quantity known as ionisation energy, which is the amount of energy required to remove an electron from an atom. Hence, metal ions have a low ionisation energy, since they easily lose electrons. Examples of metals include elements like sodium, Na, magnesium, Mg, and iron, Fe. In contrast, nonmetals typically do not form positive ions under normal conditions. Instead, they usually gain, share, or keep their electrons. This results in the formation of negative ions, anions, or covalent bonds. Nonmetals generally have higher ionization energies, making them less likely to lose electrons. Examples of nonmetals include oxygen, O, carbon, C, and sulfur, S. The periodic table is predominantly composed of metals, constituting about 75% of all elements. Metals are typically found on the left side, center, and bottom of the periodic table. This large grouping includes everything from the highly reactive alkali metals in Group 1 to the transition metals found in the center of the periodic table. Let's apply our understanding of electronic structure to some GCSE level questions. Our first question is, what is the electronic structure of a sodium atom, atomic number 11? Pause this video here and see if you can answer it. The atomic number of sodium is 11, which means it has 11 protons and, in a neutral atom, 11 electrons. So we place the first 2 electrons in the first shell. We can draw them on our diagram as crosses like this. The next 8 electrons go into the second shell. The remaining 1 electron goes into the third shell. So the electronic structure of sodium is 2, 8, 1. Now for question 2. What is the electronic structure of a magnesium atom, atomic number 12? The atomic number of magnesium is 12, which means it has 12 protons and 12 electrons in a neutral atom. Therefore, we place the first 2 electrons in the first shell. The next 8 electrons go into the second shell, and the remaining 2 electrons go into the third shell. So, the electronic structure of magnesium is 2, 8, 2. Now, for our final practice question. What is the electronic structure of a chlorine atom, atomic number 17? The atomic number of chlorine is 17. Meaning it has 17 protons and 17 electrons in a neutral atom. Therefore, we place the first 2 electrons in the first shell. The next 8 electrons go into the second shell, and the remaining 7 electrons go into the third shell. So, the electronic structure of chlorine is 2, 8, 7. By following these steps and using the atomic number to determine the number of electrons, we can easily find the electronic structure of any element. Well done! Now, let's look at some of the history behind this lesson as an extension task. Did you know that our modern understanding of electronic structure began with Niels Bohr in 1913? Bohr, a Danish physicist, proposed that electrons surround the nucleus in specific energy levels, similar to how planets orbit the Sun. Let's consider this visually to understand what he meant. On the left of the screen is the Earth orbiting the Sun. On the right-hand side are electrons surrounding the nucleus. Can you see how they are similar? Bohr's finding was revolutionary because it explained why atoms emit light in specific colors or wavelengths. His model showed that when electrons move between these energy levels, they release or absorb energy in the form of light. This discovery was crucial in advancing our understanding of atomic behavior and laid the groundwork for quantum mechanics, which is a fascinating area of study. In today's lesson, we delved into the electronic structure of atoms. For your GCSE course, You only need to know the electronic structure up to calcium, which is the 20th element in the periodic table. We learned that electrons occupy energy levels in a specific order, starting from the lowest energy level closest to the nucleus and moving outward. Each energy level can hold a certain maximum number of electrons. The first level can hold up to 2 electrons, the second up to 8, the third up to 8, and if 1 or 2 are remaining, they are placed in the fourth. We also covered how to represent the electronic structure using numerical notation. This notation helps to quickly identify the arrangement of electrons and predict the chemical behavior of the element.